In this video, we're going to learn a couple of shortcuts to finding vertex form. This will help you not have to do completing the square, which is another way to find vertex form. So there's going to be one to go from factored form and one to go from standard form. So let's jump right into it. We've talked about it a lot, but we've never formally defined it, that when you have something in factored form, you know the two roots, R1 and R2, based on it being in factored form. And because parabolas are symmetrical across the axis of symmetry, or the line of symmetry, which is right down the middle, and goes through this vertex, whatever two roots you have here, you know that the vertex, x-coordinate at least, is going to be right in between these two. So to find the x-coordinate of the vertex, all you really have to do is take the average of these two roots. So this is something we've talked about in class, but now we're formally kind of defining a little formula, or shortcut formula, to get the x-coordinate of the vertex. Just take the two roots, add them together and divide by 2, which is the average, and that'll tell you the x-coordinate. And now in general, once you have the x-coordinate, if you want to find the y-coordinate, all you have to do is plug the x-coordinate back into the original equation. So remember back when we were solving systems of equations, as soon as you found one variable, you could plug it back into the equation to find the other one. This is the same way. Once you know x-coordinate of the vertex, plug it into the equation, the original equation, and solve for y, and you'll have the entire vertex. And then once you have the vertex, you might be done, or you might need to write the equation in vertex form. And then you can just do that using the vertex. Okay. The other shortcut is to go from standard form. So when you have some equation in standard form, let's just write it real quick. ax squared plus bx plus c. The two methods that we've learned in order to go from standard form into vertex form would be completing the square is one option, or using the quadratic. Well, the quadratic formula is to get factored form. So I guess completing the square would be the technique that you would have to use. And so now we have a much quicker and easier version. But you might have noticed, if you recall, when we completed the square, we got we wrote the equation in this form, y equals a, and then we had to figure out whatever half of the middle number was squared, and it turned out the middle number was the b over a, so we got x plus b over 2a, and then we got plus some other stuff over here. But the point is, when you look at this, you can see right away that the vertex is located, or the x-coordinate anyways, is negative b over 2a. So remember, because it's the opposite sign of whatever you have here. So when we did the whole formula for completing the square and quadratic formula and all that stuff, we kept getting this piece, half the middle number squared, half the middle number squared. So you got your b over 2a here, and so that's the x-coordinate of the vertex. The y-coordinate of the vertex is whatever stuff ended up out here. This is your y-coordinate. But instead of completing the square, if you already know the x-coordinate of the vertex, like we said before, you can plug it back into the original equation, and then you can get the y-coordinate of the vertex. So the two shortcuts here: take the average of the roots, or take negative b over 2a, given the equation in standard form. The other way to remember this, let me mention, is the quadratic formula is x-intercepts equals negative b plus or minus the square root of all that stuff all over 2a. And we had mentioned, or I had mentioned in class at least, that this negative b over 2a is the vertex, and then the plus or minus tells you how far you're going to the right or to the left to get the two roots that are symmetrical across the center, which is where the vertex is located. So negative b over 2a can be remembered pretty easily using the quadratic formula as the center of the parabola, which is where the vertex is. Okay, a couple quick examples. Let's take one in standard form. Y equals 3x squared plus 6x minus 12. And say we want to get vertex form. So we identify that the x-coordinate of the vertex is at negative b over 2a. We plug in our numbers. Negative b is 6, divided by 2a is 2 times 3, and that's negative 6 over 6, which is negative 1. Now to get the y-coordinate of the vertex, we plug in this number for x. So we get 3 times negative 1 squared plus 6 times negative 1 minus 12. Negative 1 squared is just 3. 6 times negative 1 is negative 6, and negative 12. So we got 3 minus 6, which is negative 3, minus another 12 is negative 15. So the y-coordinate of the vertex. So the vertex is the x-coordinate, we said -1, y-coordinate -15. And so we can now write the equation in vertex form if we wanted to. But you can see it's a lot quicker and easier than completing the square or using the quadratic formula or using a lot of those harder techniques that we found that helps us convert between different forms. Okay, a second example, maybe we've got a parabola in factored form. So y equals 1/2 x plus 6 and x minus 3. Okay, so our roots are at -6, 0 and +3, 0. So the x-coordinate of the vertex is the average of those numbers. So -6 plus 3 over 2. And -6 plus 3 is -3 divided by 2. It's -3/2. Okay, we have to plug that back into the original equation to get the y-coordinate of the vertex. So you got a 1/2. X plus 6 is going to be -3/2 plus 6. And x minus 3 is going to be -3/2 minus 3. Okay, we're going to get a 1/2 here. -3/2, that's like -1.5. Plus 6 is 4.5. And over here we've got -1.5 minus 3 is -4.5. And it's interesting that these came out to be the same. These two numbers will always be the same because these are the two roots. And the number we're plugging in, which is the vertex, is halfway between them. So the distance in either direction is going to be the same. In other words, if your two roots are here and here, you had to go left 4.5 to get to one of them, and right 4.5 to get to the other one. So that's the distance that you spread out in either direction. And finally, if we multiply 4.5 times 4.5, ooh, what is 4.5 times 4.5? I think that's 20.25. And you take half of that. So you get 10.125. And it's negative because it was a positive times a negative. So negative. So our final answer here, sorry I'm running out of space, for the vertex, the x-coordinate was -3/2. And the y-coordinate is -10.125, which is 10 1/8. Okay, so in either case, there's a lot of options that you have, but sometimes it's nice to know these shortcuts because they can help you more quickly get to the vertex. So one of the forms is taking the average of the two roots, if you have it in factored form. The other is to use the trick -b over 2a. Those just give you the x-coordinate, then you plug the x-coordinate back into the original equation to get the y-coordinate, and there you've got it.